This is the first paragraph from the paper. So there are two questions related to the paragraph. Points to remember. So the first thing we have to remember is relation. So in relations, each pair is ordered. So 2, 4 and 4, 2 would be considered as distinct in this relation. So we have set of all relations R from S to S such that R has exactly 6 elements, and for each pair to be related under R, any of the R in the set X, A minus B's mod A minus B should be greater than equals to 2. So first we'll first check which different pairs of numbers from S can be related to each other under this constraint, under the second constraint. That gives us 1 can be related to 3, 4, 5 and 6. We have 4 pairs here. 2 can be related to 4, 5, 6. Three can be related to 1, 5, 6. 4 can be related to 1, 2 or 6. 5 can be related to 1. 3 here, 3 here, 3 here, and 6, 6, 2, 6, 3, and 6, 4. 4 here. So we can have 20 different pairs under the second constraint. And R, any of the relation R in set X needs to have one of these 20, 6 of these 20 elements. So that gives us the different number of R. The total number of possible R's is simply the total number of distinct ways to choose 6 elements from these 20 pairs, 6 different pairs from these 20. That we know is the standard result. So number of R is equals to 20 C6. Different number of R, or that simply becomes the size of X, or that is nx in this notation they used, which gives us m is equals to 20. If the value of ny and nz is k square, we are given y, the range of R has exactly one element. And z is R is a function from S to S. So R is a function. That means we have to choose exactly one from each of these 6 different sets, each different categories, so to speak. So that is, we need that one, exactly one pair from these. That means one should be mapped to a unique element. Similarly, 2 should be mapped to a unique element, and so on and so forth. So that simply becomes choosing one from each of these 6 categories. That is choosing one from the first category into 2, into one from second category, and so on. And y is the range of R has exactly one element. That is, each of these So that is the second element in each should be common. So we'll choose 6 different relations, and in those relations the second digit should be common. The second element of the set should be common. So that we can have by taking 6. If we choose the second element to be 6, then we can have this pair, this pair, this pair, and this pair. So that is, we have 4 distinct choices which won't work. So we can check for 5. We'll also have 1, 2, 3 distinct elements. Similarly, we can check that none of the others will work. 1, 2, 3, 4, 5, 6, none of these 6 will work. So in fact ny is equals to 0. We cannot have 6 different elements. You cannot choose 6 different elements from these 20 such that the second element in the set is common. So that gives us ny plus nz equals to 0 plus 36 squared. That gives us mod k is equals to, which is equals to k square, mod k is equals to 36.